right, hi everyone. Today's lesson is kind of a nice lesson. We're going to move into some more word problems. So instead of just giving triangles and trying to find angles and sides, we're going to do the same thing, but we're going to add some applications. So big focus on word problems today, and then we're going to do a lot more with word problems moving forward. The objectives are that we can find angle measurements of triangles using either sine, cosine, or tangent. While there are 6 trig ratios, we don't typically use the other 3 to find missing angle measurements or triangles since they're not on the calculator. And since we usually get to pick sine, cosine, or tangent, there's really no point in using the other 3. Okay. I can find side lengths of triangles using side, cosine, and tangent. So angles and side lengths. And then that's just going to be extended today with some word problems. All right. I'm going to go through this warm-up with you because I want to talk about how you guys can be checking your answers and get slightly different answers, but they're still correct. I know all year we've been talking about rounding, which makes our answers the same. So then it's a little bit difficult when we start getting different answers. Okay. So find all the missing sides and angles of the triangle. So just to kind of review everything that we've done so far, before this unit we would be stuck. Because this is a right triangle, we would be thinking Pythagorean theorem. But because there's only one side length, Pythagorean theorem doesn't allow us to find the other 2 missing side lengths. But trig is what allows us to actually solve for the missing sides and triangle or angles of this triangle, whereas before we couldn't. So trig is that extra step. We need an angle and a side or some combination of them. Okay, so from this angle right here, if I go like this would be my opposite side. If I go across my my 90 degree, that would be my hypotenuse, which then leaves this as my adjacent. Remember, adjacent is whatever's next to that angle, okay, but not the hypotenuse. Okay, so based off of what I'm given here, if I have an angle, and I'm going to call this x, let's say I want to figure out what x is. So if I have an opposite and I have an adjacent, tangent, so I would say tangent of 64.5 equals, and determining what trig function to use, guys, you guys should be pretty good at this point. If you're noticing that you don't know what trig function to use, you should be setting up TOA to help you, but again, you should be, if you're not at the point where you know if you're using sine, you're using cosine, or you're using tangent, then I'd probably say you need to pay a little bit more attention to your homework as you're going through. Okay, but that should be the goal of maybe this section. All right, I know it was tangent because tangent uses opposite and adjacent, and I'm looking at my opposite and my adjacent. Okay, so opposite over adjacent, I don't know what my opposite is, but I do know that my adjacent is 17. In order to get x by itself, I'm going to multiply this side by 17, and I'm also going to multiply this side by 17. So that means I got x by itself. Remember in your calculator, anytime that you reset your calculator, you're going to have to go to mode here. Mode's right here. And you're going to have to change this back into degree mode. You won't have to worry about radian mode until Math 3. Okay, so I'm going to type in 17 tangent of 64.5, and I can see that answer then, that x is about 35.64. Okay, so that makes this side 35.64. Right? Just in case this answer is wrong, I'm not going to use it to find my hypotenuse. Okay, I'm going to use my adjacent side and my hypotenuse. And based off of adjacent and hypotenuse, that would be cosine. So I'm going to say cosine of 64.5 equals my adjacent side over my hypotenuse, which we can call y. Okay. In order to solve for y, we do not move the 17. Okay, remember when you have a fraction, you never undo the numerator, always the denominator. So since the denominator is y, what I could do is this, take it back to last unit, and now it's a proportion, so I can cross multiply. So 1 times 17 is 17, and y times cosine of 64.5 is y cosine of 64.5. So it didn't get the y by itself, but it did undo the fraction. And now since this is multiplication, I can divide by cosine of 64.5. Divide by cosine of 64.5. And that's going to tell me 17 divided by cosine of 64.5, that this is about 39.49. Okay, so that means that this side is about 39.49 centimeters. This would also be centimeters. I can figure out this missing angle if I do 90 minus 64.5, which gives me 25.5 degrees. Okay. Ways that you could get the same answer, but rounded wise would be slightly different. Had I done Pythagorean theorem, once I knew 17 and 35.64, I would have said leg squared plus leg squared equals the hypotenuse squared, so c squared. Okay, so I would have done 17 squared plus 35.64 squared. That would have given me 1559.21 equals c squared. Sorry, c squared. Take the square root. So when I take the square root of this answer, I get that c is about 39.49. And you can see actually in this case they ended up being the same. But sometimes when you do Pythagorean theorem versus trig, trig is more exact than Pythagorean theorem. So sometimes this might end up being like a 4.8 or a 4.7 or a 5, 5.0. So as long as your answers are within like 100th of each other, you're probably fine. If it was like 0.32 instead of 4.9, then I'd be a little bit concerned that you made a mistake. The bigger the numbers, you can be off by a little bit. Okay, so yeah, it kind of depends. I usually just do trig, but if you end up doing Pythagorean theorem, you might get a slightly different answer. All right. And each of these are just ways that we're going to end up setting up equations where we are going to have to figure out how to do this in our calculator. So I want to talk about these first before we attach any words or stories to them. Okay. So first thing you want to do is make sure that the variable is isolated. So like in number 1, we have x by itself. So that means all we have to do is put that in our calculator. So we'll get cosine of 44. Make sure you're putting these in your calculator and getting the same thing. Remember your mode must be in degree mode. Okay, and again, all you have to do is hit mode and then change that to degree. Okay, so cosine of 44, that's going to give us that x is about 0.72. Over here, y is by itself, so I just have to type this in my calculator. That's going to give us that y is about 0.71. Okay. Over here, I need to get x by itself. Since this is a fraction, I always undo it by multiplying by the denominator. So I'm going to multiply both sides by 19. So in my calculator, I can put 19 sine of 72. I don't need parentheses for the 19, which you could if you want to. Okay, again, we're in degree mode because notice that we're putting in a degree. Anytime we have sine, cosine, tangent of a number, it's always a degree. Okay. So this is going to tell us that x is about 18.07. No units with these because we don't know what that x is represent. It represents some length. We just don't know what it is. That's the opposite side. That's the hypotenuse. Okay. Over here, if I want to get the y by itself, I'm going to multiply by 83. So I'm going to say 83 cosine of 14, and that's going to tell me that y is about 80.53. Okay. One of the most missed problems, because there's usually only one, maybe two steps in all of these trig equations, one of the most missed problems is this type of problem right here. Not because it's tangent, but because of where the variable lies. When that variable lies there, we typically think that we want to get rid of this or we want to move that numerator. Okay, but like I said in the warm-up, we've never moved the numerator. We can only move the denominator. Okay. We can do the same thing that we just did before, which was since we over here multiplied by the denominator of 83, we multiplied by the denominator, it just happens to be a y. And when I multiply this side by y, it's going to give me y tangent of 28 equals 100. Notice I got the numerator by itself, just like over here. Okay. Since this is multiplication, I'm going to undo it with division. Divide by tangent of 28. Okay, now that's one way to do this. Here's the other way that I think a lot more students tend to go towards. Like I did in the warm-up, we can just make this a ratio and we can cross multiply. So notice 1 times 100 is 100. And notice y times tangent of 28 is y tangent of 28. So you end up with the same thing. It's just a different idea of how to get there. Okay. So this is what I'm going to put in my calculator. So I'm going to say 100 divided by tangent of 28. Okay, and that's going to tell me that y is about 188.07. Okay. The other one that we tend to make mistakes on, not as much probably as this one. This one we tend to get by the time we take the test, is this one right here. If I want to get x by itself, a lot of times what we think is that this is cosine times x, since it's right as cosine of x, and of we associate with multiplication. We think that we can do this and divide by cosine. But if I were to do that on this side, look what happens in my calculator. If I were to do 74 divided by 115 divided by cosine, the calculator is not going to let me just put cosine. It wants to know cosine of what. You always have to be taking the cosine of something or sine of something. So notice it puts that parentheses in. If I hit enter, it's going to say that there's an error. And if I hit go to, it's going to say you never put anything in there. So dividing by cosine is not an option because we're not doing x times cosine. Okay, so we need to find another way to get rid of cosine. In order to undo cosine, we do the inverse of the other side. Meaning instead of doing cosine of x, we do cosine inverse of the other side of the equation. Okay, so when we put that in our calculator, we're going to say cosine, we're going to say second cosine. Notice there's the inverse. Inverse is that -1. We're going to say 74 divided by 115. So what this is telling us is what angle do we get when we have the ratio of one side compared to another side. That's 74 and 115. And that's going to tell us that our angle is about 49.95. And I can put degrees in here because anytime that the x or variable is right there, it's always a degree. Okay. Anytime, you may want to make note of this. Any time we solve for an angle, we use inverse. That means either sine inverse, cosine inverse, or tangent inverse. Okay? All right. The last three problems are all inverse. Notice that we're solving for sine. We're solving for sine of x, tangent of x, cosine of y. So this would be a good time to pause and just make sure that you can put them in your calculator and that you can solve for them. Okay. So like I said, go ahead, pause, try this on your own. Okay. So hopefully we're checking answers right now. I'm going to hit second sine of 64 divided by 131. And that's going to give me that x is about 29.25. And again, I know it's an angle, so it's got to be a degree. I didn't put anything in the other ones because I didn't know if it was feet or inches or centimeters, but degree, there's only one, so one type of unit. Okay. I'm going to hit second, tangent of 190 divided by 74, and I get that x is about 68.72 degrees. And then over here, I'm going to put second cosine of 12 divided by 7. And notice that I get a domain error. And the error, if I hit go to, notice it's coming from that fraction. Here's why. If I talk about cosine, cosine is my adjacent side over my hypotenuse. In a right triangle, is it possible for the adjacent side to be bigger than the hypotenuse side? No. So because it's not possible, the calculator can't give me an angle that makes sense. So this, we're just going to say is not possible. Or no solution, because we're technically solving for y. So it's no solution because it's not possible. All right, so word problems. Word problems and trig. Okay. When you do word problems, you are always going to draw a diagram, and you're going to take your time drawing your diagram. In this case, just a triangle, because the more accurate that your triangle is, the only way that you can get the right answer. Okay, so if you put something in the wrong place, you're going to end up with the wrong answer. Okay, so we're going to read, we're going to reread, and we're going to check. All right, it says a trucker drives 1,027 feet up a hill that has a constant slope. When the trucker reaches the top of the hill, he has traveled a horizontal distance of 990 feet. At what angle did the trucker drive to reach the top? Okay. So you're going to notice that when you look at these diagrams, triangles may be different. They may face different ways, depending on if you're drawing it or I'm drawing it. I typically draw the triangle facing the same way, and then just make the problem fit the situation. We typically draw it like this, or you could draw it like this. But we won't really get into drawing triangles upside down for at least another day or two. Okay. But let me draw it like this. Okay. So a trucker drives 1,027 feet up a hill that has a constant slope. So let's say I didn't know what that was and I kept reading. When the trucker reaches the top of the hill, he's traveled a horizontal distance of 990. The horizontal distance would be this right here, because this would be vertical and this would be diagonal. At what angle did the trucker drive to reach the top? Well, the only angles would be this one and this one, since that's 90. If the trucker is driving towards the top, that means he's going this direction, which means this is our angle that we want to know. So that's theta. Okay. Which means then this number right here, 1027, is the distance that the truck drives. The truck can't drive straight up vertically. So then that means that the only way that this number makes sense is there, because again, that truck is driving up that hill. Okay. Based off of where theta is at, this is my adjacent side and this is my hypotenuse, which means I'm going to use cosine. So I'm going to say cosine of theta equals my adjacent side over my hypotenuse. Okay, and then based off of those problems that we did up above, we should be able to solve these a lot quicker. I can see I'm going to do the cosine inverse of 990 divided by 1027. And that's going to tell me that theta is about 15.43 degrees. So he was driving uphill at a constant about 15.43 degrees. Constant slope. Okay. Sometimes, in most cases, the problems aren't too bad. When you reread, you'll start to figure out the wording that goes with the vertical, the horizontal, the diagonal, where the angles go. But in some cases, don't worry if you have to look at the answer key to kind of see how it's set up. Because once you see one or two problems and how they're set up, you're going to notice that the wording is pretty much the same for all these. We can just change the situation, change the numbers. Okay. Okay. A ladder rests against the side of a building. The ladder reaches 12.5 feet up the building vertically. how long is the ladder if it is resting at an angle of 70.5 degrees with the ground? So it's got to be a right triangle, and all of these we're talking about trig, so the only option is a right triangle. So I would start with drawing your right triangle. Okay, a ladder rests against the side of a building. It reaches 12.5 feet up the building vertically. So here's your vertically. How long is the ladder if it is resting at an angle of 70.5 degrees with the ground? So notice it says with the ground. So there's only two options again for the angle. Up here is not on the ground. Here is. So this is where 70.5 goes. And then we need to figure out where to put x. Okay, it's talking about the ladder. Sometimes we think that this is the ladder, which is sitting vertically, which doesn't really make sense because then this has no use. But the ladder is this right here. Right, it's resting up against the side of the house, which is creating a triangle. That's what we want to know. So how long is the ladder? So from this angle right here, this is my opposite. And then opposite of my 90 is my hypotenuse. So that means O and H. Take a second, think about what trig function that would be. Okay, so that would be sine. So we're going to say sine of 70.5 equals my opposite over my hypotenuse. Okay, I'm going to put this over 1 and I'm going to cross multiply. So 1 times 12.5 is 12.5. X times sine of 70.5 is x sine of 70.5. To get x by itself, I'm going to divide. And again, be careful with this one. This is probably the most missed type of algebraic solving. Usually we get the setup right, and then we mess it up with the solving. So 12.5 divided by sine of 70.5 tells us that that ladder is about 13.26. Okay, so make sure that we always have units, and the applications always have some type of unit with it. Okay. All right, moving on. Next one. Arya is standing on the ground and looking at a cat stuck in a tree. From where she is standing, she is looking up at the cat at an angle of 42 degrees from the horizontal. If she is standing 12.78 feet from the base of the tree, how high is the cat off the ground if Arya is 36 inches tall? So this one has a lot of wording going on with it. I'm going to start by drawing my triangle. Don't be afraid to make it big. Some of you guys have to try to write really small. Okay, give yourself some room, make sure that you can understand your writing. All right, so Arya is standing on the ground looking at a cat stuck in a tree. So Arya is standing on the ground looking at a cat stuck in a tree. So I'm going to do this. I'm going to say, here's my cat. I'm not very good at drawing, but I'll do my best. Okay, and here's why I'm drawing it this way. It says from where she is standing, she's looking up at a cat at an angle of 42 degrees. So this is 42 because she's looking up at the cat. Okay. Notice it says from the horizontal, meaning if she looks this way and then were to look up, because it's going like this. Okay. If she's standing 12.78 feet from the base of the tree, so that would be the distance from her all the way to the tree. So that would be 12.78. How high is the cat off the ground if Arya is 36 inches tall? So this is very important. Okay. If you're never told how tall somebody is, you can always assume that the triangle is being created, show you, from their feet, like that. However, since it's telling you that Arya is 36 inches tall, it means that it's going from Arya's eyesight. Okay, so what that means is we need to say Arya is 36 inches tall, which is the same as 3 feet, which I want to make it 3 because that's in terms of feet. Okay, that means from the bottom of this triangle to the bottom of the tree is 3 feet. the cat, oh boy, I can't draw a cat. There's a cat. The cat is up here, and we want to know how high the cat is off the tree. But based off of our triangle notice goes from here to here, so I can figure out what that is. And then if I already know that from here to here, that length, and I know this is 3, I can add these two together. Okay, so I'm going to first figure out my triangle, my trig function. From my angle, this is my opposite, this is my adjacent. So which trig function does not use hypotenuse? That would be your tangent. So I'm going to say the tangent of 42 equals x over 12.78. Okay, to get x by itself, we're going to multiply by 12.78. So let's see my calculator. I'm going to say 12.78 2. Okay, and then I can say that x is about 11.51. But again, that 11.51 goes from here to here, since my triangle's floating in the air. But then I need to go an additional 3 feet so that I can see actually how far that cat is up in the air. So I'm going to take this and I'm going to add 3, and that's going to give me 14.51 feet. Okay, again, you don't have to worry about this right here. That's just kind of a taste of what we're going to do. We're going to do some more examples with this. But you don't have to worry about this unless it specifically says from the person's eyesight, you're 5 feet tall or something like that. Okay, so those were 3 word problems. We're going to spend 2 days specifically talking about word problems. And it's usually one of the easier things of the section. As long as you've been keeping up with your homework, usually setting up and solving is pretty straightforward. Okay. All right, last 2. It says in triangle NAD, angle D is a right angle. So I'm going to draw this triangle. It does not matter how you label this triangle as long as you put this in the right place. So if angle D is the right angle, then it doesn't matter if you put M here or A here. Just read MAD, both are flipped it. Okay, so those don't matter. Just know that if you flip these and wrote A here and M here, your opposite and your adjacent are going to be flipped, but you'll end up with the exact same answer in the end. Okay, so it says the sine of M. Whenever we talk sine, remember that would be your opposite then, and this would be your hypotenuse. So again, notice we really have to know those trig functions and the ratios. So sine M means that I would be right here. Okay, so if I'm right here at M, I'll put a point there so I know, then my opposite is 20, and my hypotenuse is 29. It says, what are the ratios of cosine and tangent of A? Okay, well, the only way that I can know cosine and tangent is if I know what this side is right here. So I need to figure out that side. Since I don't know any angles, I can use Pythagorean theorem. So I can say leg squared plus my other leg squared equals my hypotenuse squared. Okay, so my calculator, I'm going to do 29 squared minus 20 squared, and that's going to give me that b squared equals 441. Take the square root, and I get a nice whole number of 20. Okay, now that I have all 3 sides, I can say cosine of A equals and tangent of A equals. So from M, this would be my opposite. This would be my hypotenuse, which makes this my adjacent. So the cosine of A would be my adjacent side over the hypotenuse. Let's see if you can do tangent. Let's check your answer. So tangent is the only one that does not use the hypotenuse. It is your opposite side over your adjacent side. Okay, and the only way that I could get these 2 as my answers was by using Pythagorean theorem to find my third side. All right, think this is the last one. Last one? Yes. All right. At this point, this would be a good one for you to try on your own. It's pretty similar to what we just did, just asking for different ratios. So try to pause this and do this on your own and then check your answers. All right, so assuming you're checking your answers, let's see what we got. Triangle TRY, and angle Y is the right angle. So Y has to go here. I'm going to put the T here and the R here, but again, you can flip-flop them. You'll end up with the same ratios at the end. Tangent would be your opposite and your adjacent. So from T, my opposite would be here. My adjacent would be here. In order to figure out the third side, I'm going to do 6 squared plus 15 squared equals C squared. So 6 squared plus 15 squared, 261. Square root of that. Alright, so since I don't get a nice number, I'm going to leave this as the square root of 261. And I want to check to see if it can be simplified. So let's see. 261 divided by 4, that's a perfect square. It doesn't work. The next perfect square would be 9. Oh, look at that. So that does work. So that means that I can break 261 into 9 times 29, which when I do that, this gives me 3. So that's going to be 3 square root of 29. Okay, notice that all 3 of these can be divided by 3. So I'm actually going to do that on my diagram. If I divide this by 3, it becomes 2. If I divide this by 3, it becomes 5. And if I divide this by 3, notice 3 divided by 3, it just becomes the square root of 29, because 3 divided by 3 would be 1. Okay, by doing that, now when I go to set up my ratios, I won't have to simplify my ratios. So I'm going to say sine R, and notice I've switched this now. R means now this is where I'm going from. So from here, my opposite side would be 5, and the hypotenuse would be the square root of 29. So I have to rationalize it. Which means I get 5 square root of 29 over 29. Okay, I'm going to do secant. And when I think about secant, I don't usually memorize secant, but I do know that secant goes with cosines. Remember, S's and C's go together. So that means I'm going to actually do cosine of R. So cosine would be my adjacent, which would be 2, over my hypotenuse, which would be square root of 29. But I didn't want cosine, I wanted secant of R, which means I'm going to take this answer and I'm going to flip it. So when I flip it, I get square root of 29 over 2. I don't have to rationalize. So don't rationalize this because I ended up flipping it anyways. This would be my answer. And then this was my answer for sine. All right, that takes us to the homework, which is number 4. In this homework, you're going to have some problems just like what we just did. And then, so the first 4 problems are kind of what we just did. And then there's 1, 2, 3, 4, 5 word problems. So if you need to go back to the word problems that we just did, go back. Don't worry if you have to go and look at the answer key to how to set up the problem, but it should just be the setup that you have to do. Once you set up the triangle, you should be able at this point to be able to set up the trig equation and solve. Okay, if you don't, let us know. Okay? All right. Bye, everyone.